When you really think about someone saying, let's invent a telescope that can see back to the Big Bang.
In the eternal silence of space, galaxies that shouldn't exist.
All these little dots are galaxies, some of which are bigger than our own.
A universe expanding at incompatible rates, ancient structures defying every law carved into physics textbooks.
The galaxies in the merging galaxies, we now see gas and dust which is being heated up in the collision between those galaxies.
Nobel Prize winner John Mather spent decades orchestrating this cosmic revelation. What he found has shattered certainty itself.
Expanding universe story that everybody calls the Big Bang was correct.
Some scientists now speak in hushed tones of a possibility once confined to science fiction, that the telescope has not merely looked deeper into our universe, but glimpsed the signature of another one entirely. The cosmos, it seems, has been keeping secrets. Since the Apollo astronauts first looked back at Earth, a fragile marble suspended in the vastness, humanity has been driven by a singular, haunting question.
Is finding things that we didn't expect, that we can't explain, because that means that...
How did all of this begin? For decades, the Hubble Space Telescope served as our window into deep time, capturing galaxies billions of years old, their light traveling across cosmic epochs to reach our instruments. Those observations confirmed the Big Bang theory, a narrative so elegant it earned Nobel Prizes and became the foundation of modern cosmology. Then, on Christmas Day 2021, atop a column of fire and ambition, NASA launched the $10 billion James Webb Space Telescope into the darkness. Led by Nobel laureate John Mather, James Webb was engineered to pierce through cosmic dust and time itself, designed to witness the universe's first light, the cosmic dawn, shining 13.5 billion years ago when infant stars ignited in the primordial dark. But when those first images materialized in the summer of 2022, something was profoundly, undeniably wrong. The universe. James Webb revealed, ancient, vast, impossibly structured, looked nothing like the predictions. Galaxies appeared where none should exist. Structures blazed with brightness that defied explanation. 3 years of observations later, the evidence has become impossible to ignore. The standard model of cosmology, humanity's carefully constructed understanding of cosmic origins, is fracturing beneath the weight of what Webb has seen. The universe, it turns out, has been telling us a different story all along. In its largest survey to date, the James Webb Space Telescope has detected approximately 10 times more galaxies in the early universe than physicists predicted could exist. But the true crisis lies not in their number, it lies in what these galaxies are. Each one represents an impossibility written in starlight. Consider JADES GSZ 14-0, a galaxy shining just 280 million years after the Big Bang, a cosmic infant barely out of the darkness. According to the Lambda CDM model, the mathematical framework that has guided cosmology for generations, this galaxy should be a faint, chaotic cloud of primordial gas, perhaps assembling its first tentative stars. Instead, James Webb reveals a massive, chemically evolved, star-forming powerhouse blazing with a brightness that should not exist in such a young universe. They're surprisingly big, bright, powerful, and numerous compared with what we expected, John Mather reflected, his voice carrying the weight of decades spent building an instrument that has now undermined the very theories it was designed to confirm. The problem is fundamental. In the current understanding of physics, there simply wasn't enough time. Star formation is a slow burn measured in millions of years. Galaxy assembly, the gravitational dance of dark matter, gas, and newborn suns, requires billions of years to orchestrate. Yet these galaxies appeared fully mature, chemically enriched, structurally sophisticated in just a few 100 million years after creation itself. It's as if humanity built a camera to photograph a newborn and discovered, impossibly, that the infant was already grown. The universe, it seems, learned to build galaxies far faster than physics says it should. But the crisis extends beyond unexpected galaxies. It strikes at something even more fundamental. The universe cannot agree on how fast it's expanding. Nobel Prize winner Adam Rice, the scientist who discovered that the universe's expansion is accelerating, driven by the mysterious force called dark energy, has spent years measuring the expansion rate in our local cosmic neighborhood. Using supernovae as cosmic yardsticks, his team consistently finds one number, approximately 73 kilometers per second per megaparsec. This is the Hubble constant, the heartbeat of cosmic expansion measured in the universe's present age. Meanwhile, measurements derived from the universe's oldest light, the cosmic microwave background radiation, an echo from 380,000 years after the Big Bang, predict a completely different expansion rate, approximately 67. Same universe, same physics, two incompatible answers. This discrepancy, known as the Hubble tension, is not a minor measurement error. It represents two fundamentally different universes existing in the same space. In December 2024, James Webb completed its largest study, confirming Hubble's measurements with over 8 sigma confidence, a statistical certainty so overwhelming it eliminates the possibility of coincidence or error. As one analysis concluded with unsettling clarity, the mismatch is not in the yardstick, it is in the underlying picture of the universe. The implications are staggering. Either the laws of physics operate differently at different cosmic scales, or something, some unknown force, some hidden component of reality, is accelerating the universe's expansion in ways that contradict everything cosmologists thought they understood. The universe is expanding, but it's expanding wrong, and no one knows why. Then came a discovery that defies not just cosmology, but the very principle of cosmic randomness. Using James Webb Jade Survey, astronomers analyzed the rotation of 263 galaxies from the early universe. In a cosmos born from quantum chaos, shaped by random fluctuations in the primordial void, these galaxies should spin in random directions, half clockwise, half counterclockwise, like coins flipped across the fabric of space-time. Instead, James Webb revealed something profoundly wrong. 66% rotating clockwise, only 33% counterclockwise. Near the southern galactic pole specifically, 158 galaxies spun clockwise while merely 105 turned in the opposite direction. This is not a statistical anomaly, this is a cosmic signature, a preferred direction imprinted into the structure of reality itself. The asymmetry hints at what physicists call a cosmological scale axis, a fundamental orientation in the universe's geometry, carved into existence at the moment of creation. If true, this would mean the Big Bang was not a singular explosion from nothing, but an emergence from something older, something vaster, a universe nested inside another like infinite cosmic matryoshka dolls. The universe, in this view, doesn't merely expand, it spins. And that spin carries memory of an origin beyond the beginning we thought we knew. The cosmos, it seems, remembers its origin from something else. James Webb infrared vision, piercing through cosmic dust to reveal what visible light cannot, has uncovered yet another anomaly in the architecture of early galaxies. Young galaxies, forming in the universe's first billion years, display unexpectedly elongated, stretched shapes. These prolate structures, pulled like cosmic taffy along invisible scaffolding, contradict the predictions of cold, dark matter models that have dominated cosmology for decades. This is why we built Webb, Mather reflected, his voice carrying the weight of 35 years devoted to a single instrument, a single vision. To answer the question, what happened next after the Big Bang? But instead of answers that settle and satisfy, James Webb has delivered a cascade of mysteries, each one chipping away at the certainty physicists once held. The standard model of cosmology, it seems, may not be so standard after all. The universe, once again, refuses to conform. But beneath the headlines celebrating cosmic discovery, a deeper tension simmers, one that reveals as much about human understanding as it does about the universe itself. NASA speaks of groundbreaking observations, yet what remains largely unspoken is the fracture running through the scientific community, a divide between those who see revolution and those who urge caution. While Adam Rice and his team insist the Hubble tension represents a fundamental crisis, proof that the cosmological model is broken beyond repair, rival physicist Wendy Friedman from the University of Chicago argues the interpretation may be premature. Her measurements suggest the discrepancy might be smaller than advertised, potentially explainable through systematic errors or misunderstood astrophysics. Other researchers have proposed that supermassive black holes in early galaxies, distorting space and light around them, could be creating observational illusions, making the cosmic crisis appear worse than reality. Even Mather, the architect of Webb's vision, admits with careful honesty, they're not quite like what we thought they were. It's a statement of profound humility, an acknowledgement that the universe observed may not match the universe imagined. So the question lingers in the space between discovery and understanding. Is humanity witnessing the birth of a new physics, a revolution as profound as relativity or quantum mechanics? Or is this a measurement puzzle, complex, confusing, but ultimately solvable within existing frameworks? The answer remains hidden somewhere in the data, waiting for time, more observations, and perhaps a leap of imagination to reveal itself. The universe has spoken, but what it's saying remains a matter of interpretation. For centuries, humanity built telescopes to confirm what was believed. Each lens, each mirror, each detector was an instrument of verification, tools designed to reveal a universe already understood in theory, waiting only to be seen. The James Webb Space Telescope was built with the same intention, but it has accomplished something far more valuable and far more unsettling. It has revealed a universe spinning in directions physics says are forbidden, expanding at rates incompatible with cosmic history, forming structures in time frames too brief for the laws of nature as currently understood. Each observation, each carefully calibrated measurement, represents not an answer, but a question, one that strikes at the foundation of cosmological understanding. Nobel laureates who devoted their lives to decoding cosmic laws now confront a possibility both humbling and profound, that those laws are incomplete. That the universe, in its oldest and farthest reaches, operates under principles humanity has not yet discovered, or perhaps has not yet been capable of imagining. The question, then, is not whether the James Webb Space Telescope has found another universe. The question, suspended in the silence between what was known and what must now be reconsidered, is whether humanity was ever living in the universe it thought it understood. The cosmos keeps its secrets, but the telescope continues to watch. And with every photon that crosses 1,000,000 years of darkness to reach its mirror, the universe whispers its truth, whether humanity is ready to hear it or not.